Hello again. We are talking about the same thing, simplifying the tangent of secant inverse of x. This is just a more general approach. This approach does not use geometry. This approach uses the trigonometric identities, which you learned in pre-calculus, reviewed in AP calculus, I know for a fact, and in general they're used in higher mathematics a lot. So, what I'm going to do before we get into the actual problem-solving process is kind of remind you of a few things. In the last video, we did talk about the reciprocal identities. Those are very useful. And those are just like the sine is the opposite over hypotenuse, tangent is adjacent over hypotenuse, which is the same thing as saying sine over cosine, so on and so forth. The other trigonometric identities that you would need to know are the Pythagorean identities, and those are related to the Pythagorean theorem, and they are as follows. Sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 is equal to secant squared theta, and cotangent squared theta plus 1 is equal to cosecant squared theta. In addition to those identities, though we might use one where we need to use it in this video, but generally speaking, other than these, which are all included as fundamental identities, we might need to know the reduction formulas for reducing powers. I'm not going to list them here, but you can look those up, and we might need to know the double angle formulas. But other than that, we should be fine with just this for most questions. Specifically with the one that we are looking at here. Tangent of secant inverse of x. And we want to simplify that down. I'm going to start off here with pointing out that the secant of theta equals x. That's what this statement here means. Secant inverse of x means that the secant of some angle equals x. We have that written down. Now we can continue to our identity. We want to know specifically what the tangent of this is, because right now what we have is the tangent of theta. Okay? Now, tangent is related to secant through the Pythagorean identity that is set up like this. Now, if we have stated that secant is x, which is what this statement here means, then we can just plug in x here. So now that equals x squared plus 1 tangent squared theta. Okay. From here we would subtract 1 from each side, and basically we're just solving for tangent. Subtract 1 from each side. Tangent squared theta equals x squared minus 1. Take the square root of both sides. So the tangent of theta equals the square root of x squared minus 1. Remember that secant inverse of x is just theta. So we now have that this equals the square root of x squared minus 1. A little bit clunkier than the last example that we looked at, but doable. Slightly more annoying. Not terrible though. We will look at one more using this type of mindset, and we are going to do that by looking at let's see. Let's do the sine of tangent inverse. Sine of tangent inverse of x. Now, to be perfectly honest with you, I would probably do this one normally using the methods we talked about in the last video. We'll get through it here, but it's not going to be near as pretty. But we can still accomplish it. So, first thing that we have here is we have that the tangent of theta is equal to x. And that tan inverse of x is theta. If you need to write that down, please do. Whatever helps you understand the process. So, what we are really looking at here is the sine of theta. But we need to get this into terms that involve sine and tangent. And the only equation that I can think of off the top of my head that relates sine and tangent is that tangent of theta is equal to sine theta over cosine theta, which technically means that sine is equal to tangent times cosine. Sine theta equals tangent theta times cosine theta. Alright, now comes the annoying part about this particular question. I only know what tangent equals. I know that the tangent of theta is x, so I know that that's x. I need to get cosine in terms of tangent, which to do that I'm going to have to use a Pythagorean identity, more specifically the same one we used above. Tangent squared theta plus 1 equals secant squared theta. Now the reason that I can use this particular equation is because secant is 1 over cosine. So what I have here is 1 over cosine squared theta is equal to x plus 1. Well, x squared plus 1, because the tangent is being squared. To solve this, I take the reciprocal of both sides. If I take the reciprocal of this and this, I get 1 over x squared plus 1, which is equal to cosine squared of my angle. At this point, still need to get cosine by itself, so I have to take the square root of both sides, which gives us that the cosine of theta equals 1 over the square root of x plus 1, well, x squared plus 1, which we know from earlier is actually just the the square root of x squared plus 1 over x squared plus 1. Now that I have tangent and cosine, I can plug it in here. So sine theta equals x for my tangent times my cosine, which would be the square root of x squared plus 1 over x squared plus 1. And sadly enough, the only way to simplify that down any further is just to put the x with the square root of x squared plus 1 over x squared plus 1. Not nearly as pretty as the last method, however, still effective. Not as pretty, but still effective. And that's really all that we can ask for sometimes. Anyway, that is it for this video. I'm sure between the two that you will find a method that you prefer, and I'm pretty sure it's probably going to be the first one. But that's okay. Best of luck. If you have any more questions, please send them